It's common for a blueprint to request that you break all sharp edges on the finished part. This type of edge break is not always modeled on the CAD part. 2D chamfer is a strategy for putting a beveled edge on the machined part. This part doesn't have any chamfers modeled on its edges. The 2D chamfer toolpath can be found under our 2D toolpaths group. On the Tool tab, press Select to pick our cutting tool. If you click on the document heading, Intro to 2D Machining, the middle section will show only the tools for this project. Pick tool number 4, the 5/16 by 5/32 diameter 45-degree chamfer mill from the list and press Select. We will leave the default speeds and feeds for this tool. Let's go to the Geometry tab. First, let's pick the outer edges of both open pockets, then along the outer contour, then the inner chains of the closed pockets. When you're done, you should have 5 chains total. Let's go to the Heights tab. Make sure that our bottom height is in reference from the selected contours with an offset value of 0. Let's go to our Passes tab. In the Compensation type, set the cutter compensation to Wear. This will allow the operator to make adjustments to the chamfer width at the machine. The 2D chamfer toolpath can be used on parts that have a chamfer modeled and parts that don't have a chamfer modeled. Mouse over the chamfer group title for details on how to select the appropriate edge, depending on your situation. In the chamfer group, set the chamfer width to 10 thousandths. The chamfer tip offset is how much the tip is going to extend past the bottom edge of the chamfer. Set the chamfer tip offset to 25 thousandths. The chamfer clearance is a distance to the edge of the tool to the sidewalls of the part. This is to avoid collisions at sharp corners. Set the chamfer clearance to 30 thousandths. Enable smoothing. If you have any questions about these parameters, remember to look at the tooltips for additional information. Let's go to our Linking tab. For the lead in and out, I want to approach with a more direct blend. In the Leads and Transitions group, set the lead-in radius to 40 thousandths and set the lead-in sweep to a 45-degree sweep angle. Set the lead-in distance to a 60 thousandths linear distance. Set the vertical lead-in radius to 0. Turn off perpendicular motion. With those changes complete, press OK. There is the 2D chamfer toolpath on all the sharp edges. Let's take a look at this in Simulate. Right-click on the setup and select Simulate. Disable Tool, Disable Toolpath, Enable Stock. On the player controls, click Go to the end of the toolpath. You may not be able to see the chamfer very well. That's because the model is still showing. In the browser tree, find Models. Click on the visibility icon to turn it off. Now the chamfer is more visible. Click on the visibility icon again to turn visibility back on for the model. Press Close to exit the simulation. In this lesson, we learned about how to break all the sharp edges of the part using the 2D chamfer toolpath. We made some adjustments to the lead-in, lead-out parameters and learned how to turn off the model display. Press Ctrl+S to save the part, Command-S on the Mac.